Hello and welcome to this presentation on my 20-hour AIM training program for Valorant, designed using the constraints-led approach. My name is Shitranjan, and over the next 15 minutes, I'll be taking you through the design, execution, and results of a structured training program aimed at enhancing target accuracy, reaction speed, and adaptability in high-pressure scenarios in Valorant. Valorant, developed by Riot Games, is a highly competitive team-based first-person shooter that has quickly gained popularity in the esports world since its release in 2020. In Valorant, players must control agents with unique abilities while focusing on precise aiming and quick reflexes to outmaneuver opponents. In competitive play, aim accuracy and reaction time are critical to achieving a high kill-to-death ratio, which is a common indicator of an individual's performance. For professional Valorant players, aim performance can be the difference between winning and losing. In competitive matches, players often achieve headshot accuracy rates above 20% with reaction times as fast as 300 milliseconds. Achieving similar levels of performance requires consistent structured practice that enhances both aim accuracy and adaptability to dynamic scenarios. This training program is designed to address these demands, helping players not only improve their shooting precision, but also adapt to varying tasks and environmental constraints that mimic real game conditions. The constraints-led approach provides a holistic framework for skill acquisition, particularly suited to complex high-stakes environments like Valorant. By focusing on individual, environmental, and task constraints, CLA promotes a type of learning that is both adaptable and contextually relevant. This is essential for Valorant players who must not develop only technical precision, but also the ability to react quickly and effectively in unpredictable situations. As the program progresses, the structured manipulation of constraints ensures that each player develops robust, transferable skills that can enhance their in-game performance, making CLA a powerful tool in competitive esports training. The goal of this training program is to improve specific aspects of aiming in Valorant, such as target acquisition, speed, headshot accuracy, and reflexive targeting. First-person shooter games like Valorant requires rapid decision-making and precise motor control, which can be effectively developed through a structured training approach. To achieve this, I use the constraints-led approach, which emphasizes learning through dynamic interactions between the individual, task, and environmental constraints. Unlike traditional repetitive drills, the constraints-led approach is widely recognized for promoting adaptability, as it encourages players to adjust their actions to variable conditions, leading to better skill transfer to real game scenarios. I hypothesize that a structured training program utilizing this approach will lead to measurable improvements in aim accuracy, reaction speed, and target acquisition consistency. This method is expected to yield more adaptable, game-ready skills compared to traditional repetitive drills, which may lack the flexibility required in dynamic environments. The core concepts that inform this program focusing on the types of constraints: individual constraints, environmental constraints, and task constraints. Individual constraints refer to player-specific factors like hand-eye coordination, reaction time, and cognitive processing speed, which influence how each player responds to aiming tasks. Environmental constraints include external conditions such as game settings, lighting, and auditory distractions. Task constraints relate directly to the aiming tasks, such as the movement and speed of targets. By manipulating task constraints, players gradually build the ability to handle complex aiming tasks, transitioning from basic to high-stress conditions. By leveraging these constraints, this program encourages players to adapt and perform under varied and challenging conditions. This training program is structured into 4 phases, each designed to develop specific aiming skills through progressive challenges. The first 3 phases are conducted in Valorant's built-in training range, providing a controlled environment that allows players to focus on specific aspects of aim without the distractions of a full match. Each phase is designed to be completed over a duration of 5 hours, totaling 20 hours for the entire program. Phase 1 is shooting static targets. The goal of this phase is to build foundational accuracy by practicing on stationary targets. This is essential for developing precise control and aiming consistently, which serves as the groundwork for more complex aiming tasks. Phase 2 will focus on the moving targets. This phase aims to improve tracking ability by having players engage with moving targets. Effective training is crucial for dynamic gameplay, as it enables players to maintain their aim on opponents who are constantly moving. Phase 3 focuses on reaction and flick shots. This phase focuses on enhancing reflexive accuracy and reaction time, training players to quickly locate and target enemies that appear suddenly. Quick reflexes and accurate flick shots are critical in high-stakes scenarios, such as responding to opponents who suddenly appear around corners. Phase 4 is a high-stress scenario. The final phase is designed to apply all learned skills in a realistic high-pressure environment by stimulating actual game scenarios. This phase ensures skill transfer by introducing live opponents and full gameplay settings, which are essential for effective adaptations. For Phase 4, players will engage in Valorant's deathmatch mode, where they face real opponents in a high-stress, fast-paced environment. This mode will introduce environmental and task complexities, as players must respond to moving, shooting opponents, and utilize the map effectively. Also, for Phase 1, the task complexity is kept quite low, allowing players to concentrate solely on precise aiming mechanics. But as we move on to Phase 2, the introduction of moving targets increase task complexity, challenging players to adapt their aim and maintain focus on dynamic targets. The environment constraints in Phase 2 is to mimic in-game scenarios. Players may introduce mild distractions towards the end of this phase to practice tracking in a semi-distracting environment. For Phase 3, this phase introduces random target locations, requiring players to quickly locate and react to sudden appearances. This randomness closely stimulates in-game situations where enemies appear from various directions. As with the individual constraint, players are encouraged to increase their in-game sensitivity slightly to help with faster flicks, but they must balance this with maintaining control. As for Phase 4, the full environmental elements are present, such as game sounds, footsteps, and background noise, which players must learn to manage effectively. As for the task constraints, the unpredictability of real opponents who can appear from any direction and at various distances forces players to adapt continuously. Now coming on to the results, we first focus on reaction time. Reaction time is the time measured in milliseconds it takes for a player to identify a target and respond with an accurate shot. This is particularly important for reflex-based aiming situations where players need to quickly react to opponents who suddenly appear on screen. Reaction time is a strong indicator of cognitive and motor efficiency, as it reflects how quickly the brain and body can coordinate to execute a response. Players were tasked with flicking to each target as quickly as possible, aiming to reduce the average response time to each target appearance. Where players were tasked with flicking to each target as quickly as possible, aiming to reduce their average response time to each target appearance. Faster reaction times improve a player's ability to handle surprise encounters. We now focus on the hit accuracy. Hit accuracy is the percentage of shots that hit the target out of the total shots taken. This metric reflects the player's aiming precision and ability to consistently target opponents effectively. In Valorant, high accuracy is essential because precise shots are required to eliminate opponents quickly, especially when aiming for headshots. Hit accuracy was assessed at the end of each phase by recording accuracy scores in Valorant's training range as well as in deathmatch mode in phase 4. Players were encouraged to aim for headshots to improve their accuracy and reduce time to kill, which is crucial in competitive gameplay. The overall performance score is a composite metric provided by aim training software such as AimLab, but you could also use Valorant Stat Tracker, or you could use the Valorant Training Range Score Tracker. The score reflected the player's cumulative performance, accounting for accuracy, speed, and consistency across different types of aiming challenges. Also looking at the results, his pre-training accuracy averaged at 50% for static targets and improved to 88% post-training, showing a 76% improvement in aiming precision. As for when the target started moving, his pre-training score was 28% and his post-training score was 62%, showing a 121.43% improvement. As for his flicks on the third stage, his pre-training score was 38% and increased to 70% by his post-training, showing an 84.21% improvement. His reaction time dropped from 450 milliseconds pre-training to an average of 310 milliseconds post-training, indicating faster response times. And on the final stage, his initial kill-death ratio was 0.82 in deathmatch mode, which improved to 1.31 by the end of his training. And as you can see on the line graph on the right, his accuracy from pre-training till post-training steadily increased, spiking a bit between phase 2 and phase 3. And these improvements across all these results support the hypothesis that a constraints-led approach can effectively enhance performance in dynamic environments like Valorant. The results show that the constraints-led approach promotes skill adaptability, which is essential for realistic gameplay. This approach's strength lies in its progressive difficulty and realistic training scenarios, which simulate the in-game demands. However, there are a few limitations. One limitation is that the focus on isolated aiming skills may not account for other factors in competitive gameplay, such as movement and team coordination. Another constraint could possibly be how experienced the person is in first-person shooters and in Valorant in particular. In this situation, I was the client and I have over 1,000 hours on this game, so I was familiar on when to progress or regress during my training program. And on the clip on this slide, at first, for my reaction time and flick training, the bots were set on easy, but by the last session, as I was more comfortable and experienced in the training program, the bots were set on hard, requiring a faster response time. But this may not be the case for another client, as they may not progress at the same pace, but they would improve over time if they stuck to the program. So in conclusion, this 20-hour program, grounded in the constraints-led approach, resulted in measurable improvements in accuracy, reaction time, and adaptability in Valorant. This approach shows potential for esports training by fostering flexible skills essential for dynamic performance. The references I used for this project are on the next slide. And thank you for watching. Hope you have a great day.